Hello, now we are going to talk about JK Latch. As you know that Latch is the level triggered asynchronous device. Already we have earlier discussion about SR Latch and D Latch. Today I'm going to discuss about JK Latch. So if you'll observe that in case of SR Latch, there was condition that was forbidden, or you can say that later when we have seen with the help of enable inputs that when both inputs are 1 1, that was called as the indeterminate state. So that we are going to overcome here in JK latch. So JK latch is also known for race around condition here. So what was the problem with SR latch that we are going to overcome here in JK latch? So here output is going to change rapidly. Q and Q dash both are going to change rapidly when inputs J and K both are 1. So that is called as race around condition when J is 1 and K is also 1. In that case, outputs are changing rapidly. So now in case of, if you see that in JK flip-flops, this problem is going to overcome, and here we are going to get the output, which is the toggle output. So race around was there. Now we are going to overcome of that. So even both inputs J and K is 1 1. Now we have toggle outputs. So toggle outputs means if we have Q is like this, then we have Q dash will be in this format. So which is called as the toggle output. So in this, now we'll see that since we have designed JK latch with the help of NAND gates, and in case of NAND gate, we know that whenever any one input is 0, we are sure that output is 1. So here in initial stage, we have enable is 0. So enable is 0 means if suppose device is going to work for the active low enable, then if enable is 0, then it will accept the input from the J and K. But here we are going to consider active high enable. So our device is going to give the desired result when enable will be equal to 1. So when enable is 0, it is not going to accept the input from the J and K. What was the previous state? That will remain the same even we have enable equal to 0 in this stage. So now in our case, since we are considering active high enable, so here we are going to consider En equal to 1 always. Now we'll see one by one situation. Suppose for example, so remaining operation, if you see that when we have J equal to 0, K is 1, it is same as the SR flip-flops. Sorry, SR latch. And when we have J equal to 1 and K equal to 0, again it's going to behave same as the SR latch. Only when J and K both are equal to 1, in case of SR latch, when S and R both are equal to 1, there we have indeterminate state. But here that we are overcome of this now, so that we are going to get the toggle output here. So now we can see few condition here how this JK latch is going to work. Suppose for example, first we are keeping here J equal to 1 and K equal to 0. So now two inputs, we are aware of two inputs here, and since this is designed by the help of NAND gates, so when any input is 0 to the NAND gates, we are sure that output is going to be 1. So here k we have taken as a 0. So we are sure that about NAND gate 2, our output is what here? 1. Similarly here J is 1, enable is 1. So NAND gate, we'll see that here on the basis of this also. J is 1, En is 1. So NAND gate 1 output is going to be 0. And if you'll consider enable situation here, so En is 1, K is 0. So that finally NAND gate 2 output is also 1 here. Now if we come to the here cross coupled latch where we have NAND gate 3 and NAND gate 4. So if one input is 0, we are sure that output is going to be 1. So that's why NAND gate 3 output is 1. Now this 1 is given back here. So both inputs are 1. So NAND gate output becomes 0. So Q is 1, Q dash is 0. So now device in the set condition. So now this, if you see that another condition, now suppose it is in the set condition, now we are going to make the change of the inputs. J will keep as 1 and K we are going to keep as the 1. So now this is J, this NAND gate 1 is connected with Q dash. So Q dash is 0. So that 0 is going to be the input here and Q is 1. So that another input to the NAND gate 2 is going to be 1. So now we'll try to analyze the situations. Now J is 1, Q dash is given that is 0, enable is 1. So that output of this gate should be here going to change, that is going to be 1 here. Similarly, we are seeing for the NAND gate 2. So all three inputs are high. Enable is 1, K we have to change to 1, and Q is 1, which is given here. Input, all three inputs are 1. So this output is what here? 1. So now here if you see that in this case, now we have 1, both inputs are 1, 1 here. So that in case of SR latch, we are struggling. So now here, if you see that this 1, what was already Q here, that is given input here. So both inputs become here 1, 1. So output is what here? 0. And this 0 is given input here. Now input to the NAND gate 3 is 0 and 1. So now here output is what here? 1. So this output Q and Q dash is the toggle here, even if both inputs are 1. So that is the benefits of the JK latch over the SR latch. And already we have discussion about this race around condition. So this is famous for J equal to K equal to 1. Now, what is the next state here that we can generalize with the help of expression also? So that is given as J Qn dash plus K dash Qn. How we are going to get these states? This is also called as the characteristic equation. So if you are going to take the K map, so later we'll see about this also in the conversion of the flip-flops. There we'll see that how we are able to get the characteristics equation. So if in place of enable, we are going to apply the clock pulse, then it will become the flip-flops. And later we'll have other discussion. So finally, we are going to conclude here about the JK latch. So JK latch 0, 0, inputs 0, 1, 1, 0, it is same as the SR latch. Only when we have J and K both are equal to 1, then outputs are toggles. Here outputs are not indeterminate like SR latch. Thank you. Thank you very much. Keep on seeing and keep on improving your knowledge. Thank you.